Here are our Module 9 notes, probability rules. This is page 6. We are now going to look at finding probabilities using a contingency table. A contingency table basically just lays out everything that can happen in every possible combination. So let's take a look at example 10. We've got a large group of friends getting together for game night. They decide to take a survey of which games each player wants to play as well as what they want to have while playing. So each player could only choose one game and one snack. The results of the surveys are shown in the totals below. So let's talk about how we read this. The number of people that want pizza rolls is totaled down here 44. So there are 10 that want pizza rolls and to play poker. There are 8 that want pizza rolls and to play Trivial Pursuit. There are 14 that want pizza rolls and to play Monopoly, and 12 that want pizza rolls and to play Catan. Okay. So all of these labels up here have totals down here. If I add that 44 plus 41 plus 30, it equals this 115. It works the same way across the rows. So if I take a look at how many people want to play poker, it's the 10 that also want pizza rolls, the 3 that wants chips and dip, and the 12 that wants cookies, for a total of 25. So our rows also follow the same rule. When I add all of these together, I also get 115. So everything in this table has to make sense. Okay? We want the probability that a randomly selected person wants to play poker. So the probability that somebody wants to play poker is our total of 25 poker players out of the 115 total that we have. Again, I'm not going to worry about reducing this. If we do need to combine later, we're going to want a common denominator. So we're going to leave it like this. Find the probability that a randomly selected person wants cookies. So we've got the probability of cookies. And we take a look down at our cookie total. We have 30 total people who want cookies out of the 115 of our friends. That's an awfully large party to be playing games. But that's fine. All good. Find the probability that a randomly selected person wants to play Trivial Pursuit and have chips and dip. So here's our Trivial Pursuit. And here's our chips and dip. So we are looking for the overlap. Here are all my chips and dip. Here are all my Trivial Pursuit. So it's this 14 right here that want to play Trivial Pursuit and have chips and dip out of my 115 game players. Okay. Notice there, that one's a little different. That one has an and. So I am only looking for where both of those happen. D, we now have an or. Monopoly or pizza rolls. So here's everybody that wants to play Monopoly. Here's everybody that wants pizza rolls. Now notice, it's okay if they want poker and pizza rolls. We are looking for everybody that falls into either one of those categories. So I could add these up separately, right? I have got poker and pizza rolls, there's 10. I have got Trivial Pursuit and pizza rolls, there's 8. I've got Monopoly and pizza rolls, there's 14. Catan and pizza rolls, there's 12. Plus, let's go along the Monopoly row. I've got Monopoly and pizza rolls, which we've already counted right here. I don't want to double count it. So I'm going to move on Monopoly and chips and dip and Monopoly and cookies. Okay, so wrap your head around what happened there for just a minute. Here we get 78 out of our 115. We know the formula here. It's the probability of Monopoly plus the probability of pizza rolls minus the probability that they both happen. We want to uncount the repeats. So the probability that they want to play Monopoly is 38 out of 115. Probability they wanted pizza rolls was 44 out of 115. Minus, there are 14 that want to play Monopoly and have pizza rolls. And I get 68 out of 115. And it's nice that I've done this both ways, so I can go back and I can fix my mistake back here. This should be an 88. I didn't add 17 and 7 at the end. I added 17 and 17. But in any case, now that I fixed my mistake, we get the same probability both ways. We don't always have the table to work from, so it's important to understand how the formula works. It's nice to have the table there because then we can always double check. So E, the probability that a randomly selected person wants to play Catan or have cookies. So here is our Catan players. It's this light gray. We have 23 out of 115 that want to play Catan. Plus, here are our cookies. We have 30 out of 115. Minus the overlap. So here's Catan and cookies. We've got an overlap of 4. So my denominator is going to be 115. I've got 23 plus 30, which is 53 minus 4. The probability that a randomly selected individual from the party wants to play Catan or have cookies is 49 over 115.